Today I will start with signal and systems. Just remember one thing, you have to practice a lot, and I will cover almost all the concepts. Please listen and see carefully. All the best. Topic 1, Operation on signals in continuous time. So let us first discuss what is continuous time signals. Now we take an example of continuous time signal as shown on the screen. Now we will plot the same signal in discrete time. So we will take the x-axis as shown on the screen. Here the x-axis is n. N is always an integer. So you can compare it from the time domain, the continuous time signal, to discrete time signal, and by comparing we can draw the lines as shown on the screen. Remember, the length of the line are according to the continuous time signal. So I think you can easily compare what I am trying to say. So let us take the first operation, time shifting. It is represented by y of t is equal to x of t plus alpha. Here xt is the original signal on which the operation is performed, and after performing the operation we get y of t, and the operation is x of t plus alpha. So here are two cases. Case A, alpha less than 0. So let me draw x of t as shown on the screen. Now x of t minus 2. As alpha is less than 0, so I have taken minus 2. So I will draw the waveforms. So note that there is minus 2. There is minus. So it means plus. So I am drawing it with pencil. We will add plus 2 in on every point in the time axis as shown on the screen. That is minus 2 plus 2, 3 plus 2. So what we get, the final points, 3 plus 2 5 and minus 2 plus 2 0 as shown on the screen. So this is the time shifting when alpha is less than 0, and this is called time delay. Case B, alpha greater than 0. So again I am drawing x of t. Now I have to perform x of t plus 2. So here it is plus. So we will subtract. That is minus 2 and 3 minus 2 as shown on the screen with pencil. So the new points are minus 2, that is minus 4, and 3 minus 2, 1. So we get the signal like this. I hope you got. And this is known as time advance. So as you can see, the signal is advanced. That is, previously it was starting from minus 2, now it is starting from minus 4. So remember that in time shifting operation, the width of the original signal and the width of the shifted signal is same, as you can see from the figures clearly. Now we will discuss time scaling. So its notation is y of t is equal to x of alpha into t. So let me take case A, that is alpha greater than 1, and now what I have to perform, y of t is equal to x of 2 into t. So alpha is greater than 1, that is alpha is 2 here, and now I have to perform, that is 2 into t. So it is multiplying, so we will divide. Minus 2 by 2, 3 by 2. Remember this. If it is plus, then it is minus. If it is minus, then it is plus. Now it is multiplication, so we will divide. So we will get the new points. Minus 2 by 2, minus 1, 3 by 2, 1.5. So this is my new signal. This is known as time compression. Now case B. Alpha is less than 1 and greater than 0. Okay, remember this. So y of t is equal to x of t by 2. So what is alpha here? 1 by 2. So here it is division. So in the original signal, I will multiply by 2. Minus 2 into 2, 3 into 2. And what I will get? Minus 2 into 2, minus 4, 3 into 2, 6. So this is my new signal. So what it is called? Time expansion. So this is time scaling. Now operation 3, time reversal, or it is also known as folding. So here it is represented by y of t is equal to x of minus t. So the original signal is x of t. So now we'll perform the operation. So what happens in the time reversal? So in the right of the y-axis there is 3. So it will come to the left and will become minus 3. And what is at the left of the y-axis? Minus 2. So it will go to the right of the y-axis and will become plus 2. and we will get the figure like this. So this is time reversal of folding. Now we will see another operation, and it is not an operation, it is just an insight, and you must remember this and should not confuse between time reversal and this. This is y of t is equal to minus of x of t. So what it actually is, x of t is, as we know. So what we will do, we have to minus of x of t. So minus of x of t means what is the value of x of t will be multiplied by minus 1. So what it will do, the curve will go below the x-axis. If it is, initially it is above the x-axis. I hope you got it. So it will be like this. So now we will see one problem. X of t is equal to this as shown on the screen. Now we have to perform this operation. Y of t is equal to x of minus 2 into t plus 6. So there are two ways to approach to this problem, either from right hand side or from left hand side. For simplicity, and I will advise you to go always from right hand side. And for the LHS, and to go from LHS, I won't discuss that solution in this video. So we will go from RHS. So first in RHS it is plus 6. So I have told you, if it is plus 6, then we have to do minus 6. So 3 minus 6, minus 1 minus 6. So what are the new points? Minus 7 and 3 minus 6 is minus 3. Now what it is doing, signal 2 into t, that is time scaling. So 2 into means multiplication, so we have to divide. So minus 7 by 2, minus 3 by 2. Okay, now there is minus sign. Minus means time reversal. So now minus 3 by 2 is there, that is minus 1.5. So it will go to the right of the y-axis and will become 1.5. What is there? Minus 7 by 2, that is 3.5, minus 3.5. So it will go to the right of the y-axis. So what it will become? 3.5. So what actually you have to do? You have to fold the signal. Like what is in the left will go to the right, and what is in the right will go to the left, and the signal will be as shown on the screen. Thank you. Hope you got whatever I was trying to say.